Now let's review some of the displays from this notebook. They're quite interesting, actually. So first I'm going to go to section 2.1, which is the polar expression, or the definition for the polar ellipse. And we don't have a string of input-output cells, but rather a coherent connected display. Now I'm going to push this button here, and a piece of the document has expanded in place. And this is a coherent connected display that gives a starting point for the development. This is generated by the button that I just pushed in the textual discussion. We have some dynamics in that the red point can be moved. So you can see what we mean here about this is an active document. The actual steps in this small piece of derivation are shown with comments. Here are all the steps. Constant sum, distance to the focal points, the cosine law, solve for the ellipse equations for R, and the underlying Mathematica steps are shown in tooltips, as you can see here. So clearly this shows a lot of things that a regular book would not. Now the next one I want to go over here is much more detailed, and it's in section 2.2, and it is the Cantrell derivation of swept area. So let me click this, and then you can see here this big section expands itself into the document. You can scroll back and forth in the same way here. Now this is a rather extensive derivation, but it's shown in a very organized manner, starting with a problem statement. In this case there are 9 pages, 2, 3, 4, 5, 6, 7, 8, 9. And the currently shown page is highlighted in gold. Now the derivation contains much more detail and explanation than the internet version, yet it does not drag on for 5 or 6 pages. Rather, the reader can click back and forth to relevant portions he might want to examine. So I'm going to click on a couple of these here. You can see how it changes to gold. And Kepler's stretch shows how Kepler calculated by changing the ellipse into a circle. The derivation shows how this affects the calculation. So let's, again, so this is in the middle of the document. It expanded. It's like another page. And then it also has direct manipulation. So I can change here how a circle is changed into an ellipse. Here's an explanation. Here are the steps. And here is the various Mathematica statements. So let's go back here to, you can see area calculation. A lot of material here. Trig identities shows various identities that are used in the derivation, along with all of the Mathematica code. These are in the form of active mathematical rules. Half angle and wrong angle are rather caveats that explain one of the tricks of the derivation. This kind of material might be missing from a shorter form of presentation. Theta calculation is the main derivation sequence. It makes extensive use of the trig identities. In some cases, we show the trig identities in comments. But we can bring up the trig identities in a separate window by clicking the gray button. So if I want to review them both, here they are one at a time. So let's click on the gray button here for trig identities. And you can see it brings up another window so you can sort of compare them at the same time. Okay. We can use the half angle, cotangent, and tangent identify and simplify using half angle identities, and these are given in a separate window. The reader is provided with a much more detailed information and in more convenient form than is conventional. The swept area plot shows the result of the derivation. A formula for the swept area of an ellipse that is continuous over any number of orbits. The generated knowledge was immediately usable, for example, to make the plot. For high eccentricity, the scale of the curve is poor, so the adjust vertical range can be used to change the y-scale to better display the curve. And this is completely directly manipulable, if that's a word. So if I move this over here, I can adjust the vertical range, and it modifies. Let's try this. Yep. So to adjust the vertical range, then of course you can reset the vertical range to better display the curve. We can adjust the eccentricity with the slider, or we can type in a value. So I'll put in 6062, and it makes it almost flat. So finally, we can see an interactive depiction directly integrated into the medium itself. So obviously, this is a very extensive capability here that is what we're calling an active document. Now, the next section I'm going to do is an animation, show you an animation in section 4.2 here. And so earlier I was showing you how the some of the calculations are directly in the document. So if I go down here to section 4.2, where I've evaluated a lot of things, an Earth and rotational solar satellite animation comes up. And we'll just wait here a second. And it's generating the animation. And you can see the animation here. Now this is pretty interesting to me, because not only is it direct, sort of like the Java thing, it's running on its own. I can speed it up. I can slow it down. And I can even stop it and control it myself at my own speed. Now, more powerful than this even is the fact that I can actually rotate the graph and then start it again automatically. So obviously, compared to a picture in a document, this would not, there's no comparison actually. This is much more powerful. So to wrap this up, we've talked about the past, 3,600 years of equations, diagrams, and textual discussions. Much progress in content, but little change in the static medium. The advantages of the static medium, very adaptable to all subject matter. The disadvantages, there's a lot of work to go from the concepts to the printed medium, more work to go back to actively usable material. There's a constant plague of typos and other errors, and it requires constant checking both by the author and the reader. In the future, active dynamic documents will contain directly usable generated knowledge, high integrity, smooth flow from development to communication, more effective communication. This is not marginal. This is revolutionary. Now, there was something back here I wanted to show you, a plot, this plot right here. So if I want to grab this plot out of the document and do it a little bit differently so I understand it better, I can just grab that. And if I want to put 11 here, whoop. So obviously the plot looks quite a bit different than it did in the document, or not really different, but the scale helps you to better understand what's being displayed. So this is very powerful, obviously, and we believe that will make an impact upon pedagogy and teaching of mathematics and science in the future. Thanks for watching.